on up. So I need one person from each group to come up and write down some data for me for, so we're going to say group 1, 2, 3, 4, 5. We had 6 groups, correct? Okay. And we're going to do trials 3, 6, and 9. Does that make sense? So I'm going to have you write down the data so group 1 is going to write numbers here, here, and here. You with me there? Does that make sense? Oh, I'm sorry. No, I'm sorry. I didn't mean 3, 6, 9. I meant 3, 5. You did 7 trials, right? Okay, sorry. I was thinking multiples of 3 instead of odds. 3, 5, and 7. That's what I meant. Thank you for saying that, because otherwise I would have been like, you know what? Yeah, so trials 3, 5, and 7. Does that make sense? So come on up. Somebody write down your trials information, and the other person can come up and get 2 pieces of graph paper, a red, a green, and a blue colored pencil for each person. So you need to get 2 reds, 2 greens, 2 blues.
Oh, shoot.
So everybody should be up doing something.
Do I round that to
So you're
0.6?
going to you and for your partner. You say,
Yeah. Average it up.
5 seconds. So, graph paper, masking tape.
Let's see. 5, trial 3. Can I put my hand on it without freaking out? 1.65. Get a trial 5. Right. 0.85. And 7. 4.3.
Huh? Oh, you're not doing one. Those are usually for you. I am.
So everybody should have a piece of graph paper in front of them, as well as a red, green, and blue colored pencil. We're eagerly awaiting the data, which is on its way right now.
Where do we put seconds?
You could do, good question. You can just leave it. I'll put time in seconds at the top. Thanks for checking. Are you excited? Yeah. Everybody's going to do it. So everybody should have graph paper. Everybody should have colored pencils. That's why the person that came up, I was hoping would get 2 of each so that everybody could share. Or if you didn't have to share, you could everybody have it.
Which one is that?
Oh, did you get the icky one? Yeah. I'm sorry. This would be hard to graph on. This was I attempted to graph on 2 sides and it didn't work. Or copy on 2 sides.
Oh,
Is it possible that those are point whatever? But you guys were at the front, right?
Yeah.
Okay, so I think it was actually. I'm gonna put decimals, just like looking at what everybody else had. Yeah. Is that okay? Yeah. Awesome. Okay. Nice work, friends. Now we've got a whole set of data. Because we're being thorough, and I appreciate your question, we're going to write time in seconds up there. You do not have to copy the data down. That seems like a lot of work for not a lot of payoff. So I'm just going to make this a little bit smaller. Maybe not. Okay, I'll do it in a minute. What I would like for us to do, I'm going to get myself some graph paper here, And then we are going to graph this. So in our experiment, what was the independent variable? Oh, and actually, hold on just a second before I do that. Instead of writing group here, any other idea what I could write there? Do you know how far apart you were?
A foot, 2 feet.
Good guess, except we're in science class.
Oh.
We were a meter apart. Yep. So I'm going to call this, I'm going to write this as distance. And it really is in meters. What was our independent variable? What was the thing that we chose as experimenters? Or Ms. Carbeling chose? Yeah.
Speed of the ball.
We kind of did choose the speed of the ball, but did we measure the speed of the ball anywhere? Like, we didn't have like a speedometer, right? Or like a little, radar gun. So we are going to find out the speed, aren't we? Yeah, that's where we're walking to. What was the thing that you as experimenters or I as the lead experimenter chose when we were setting up this lab? The distance, right? So this is technically the independent variable, right? That's the thing that we chose. What was the dependent variable? Dependent means it was dependent. So let's look at just trial 3. What was the dependent variable? Yeah, she says with confidence. Time, yes, it was. The person that's 1 meter away measured a time depending on how far away they were, right? Yeah. Now I did throw in the different speeds, right, that we'll get to. But yes, for any one of our trials, the dependent variable was time. I told you a couple days ago that we're always going to put the independent variable where and the dependent variable where. Do you remember? Independent on the X, dependent on the Y, right? Then I said, except for one time. Welcome to today. Today is the one time. On your graph paper, we're going to put time on the X-axis. You'll see why in just a minute if you don't know already. And we're going to put distance on the Y-axis. Oops, and distance was measured in meters. Thinking about scale, yours will be a little bit different than mine. What's the maximum that it needs to go to on the Y-axis? What's the biggest distance that we have? 6. So we need to go up 6. What's the maximum on the X-axis that we need to go to? To find the biggest number in here. These have decimal points in front of them. Let me put those on there right now just so that it doesn't get confusing. I'm going to make that just 5.5. Is that okay with my group 1 people? What's the biggest number? 5. So like maybe 5.5 or something. Okay. So I'm going to give you a minute right now to work on your scale. Talk to your table mate or talk to your partner, I'm saying, and spread out your scale as much as you can. Okay. Spread out your scale as much as you can. You don't need to start plotting anything. Just do this with your pencil or your pen if you have to, or I can let you borrow a pencil if you need one because I've got some here. Pencils are always best.
Oh, really?
And once you've got your scale figured out, I'm going to go ahead and tell you this. I want you to graph trials 3. So all of the data in that column, graph it in red. Okay. Trial 5, graph it in blue. Trial 7, graph it in green. If the color isn't working for you because you're color deficient, colorblind, or anything like that, then just go ahead and do all of these like as dots and then X's and then stars or something, and that is absolutely fine. But I want you to be able to distinguish between like everything that's trial 3 is the same, everything that's trial 5 is the same, everything that's trial 7 is the same. Does that make sense? Go ahead and get started on that graphing process. Any questions? I'm super happy to answer them. All right. Oh, no, okay. As long as I can see where your origin is. Yeah, it doesn't matter which way you do it. So distance, so the point is going to be something that's way here, and then it's going to be on the other side. So this is like so these are like divisions. No, it's okay this way. Yeah, you should do it. Yeah. Does that make sense? Yeah. So your distances and your points don't have to be exact, but we're just trying to get like as close as we can to figure it out. So your trial 3 things are going to be, so it's going to be like 1 and then like that. 2 is going to be like that. 3 is like here. 4, oops, whoa, hello. 1.34. 5. 1.65. 6 is about 2. You guys are so quiet. Are you thinking really hard? Is that what's happening? Don't connect the dots. Nope. It feels really funny, doesn't it? You like connecting dots? I can print you off some connect the dots if you want me to. I'll just Google it. Oh, I'll totally do that. Like, I'm sure I can find some good sciencey ones. I'll put it on my list of things to do this weekend. Oops, 4.31. You guys took really good data. That's really good. My experience. So nice work. Usually if the data's bad, I blame the ball thrower. But I don't know if I can give all the credit to the ball thrower if the data's all good, obviously. Yeah. Okay, cool. I thought I pulled them out. Apparently, there's no which ones.